Okay, so for this question, a body of mass 2 kg makes an elastic collision with another body at rest and continues to move in the original direction with a speed equal to half of its original speed. What is the mass of the second body? So let m1 be the mass of the first body, which is equal to 2 kg, and m2 is not known. Now let u1 be the initial speed of this body, and u2 be the initial speed of second body, which is at rest, so it's 0. And after collision, v1 is uh, equal to half of its original speed. That's the final velocity of the first body is equal to half of the original speed, which is u1, and its final speed is not known. And it's given that it's an elastic collision. So we'll try to make two equations. So let's first use law of conservation of momentum. So according to law of conservation momentum, we know that it's m1 initial momentum. That is, the momentum remains conserved. So initial momentum is equal to final momentum. So m1 is 2, u1 is not known, m2 is not known, u2 is 0, m1 is 2, final velocity of first one. So final velocity of the first body is half of the original velocity, and m2 is not known, v2 is also not known. So this gets cancelled. So finally we have 2u1. So this is 2u1 is equal to m2 into 0 is 0. So it's u1 plus m2 v2. So 2u1 minus u1 is u1, which is equal to m2 v2. Okay, let this be equation 1. And it's also given that it's an elastic collision. So for elastic collision, we know that coefficient of restitution is equal to 1. For elastic collision, coefficient of restitution is equal to 1, and coefficient of restitution is given by velocity of separation, which is v2 minus v1 upon velocity of approach, which is u1 minus u2 is equal to 1. Now v2 is not known, v1 is half of the final, half of the original velocity of the first one, u1 is u1, u2 is 0. So this gives me v2 minus half of u1 is equal to u1. So v2 is equal to u1 plus half of u1, which is equal to 3u1 by 2. And now we know that u1. Okay, so we can put in the value of u1 from here, which is m2 into v2. So this is v2 is equal to 3 into m2 into v2 by 2. v2 gets cancelled, and finally we have m2 is equal to 2 by 3 kg, which is equal to 0.67 kg. So 0.67 kg is the mass of the second body.